Welcome to Driven. I'm your host, Paul Perrone. We're going to learn and talk about AI, robotics, autonomous vehicles, and so much more. Check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. So kick back or buckle up and become driven. Sandra, thank you so much for joining me here. You're joining me from where in the world are you right now?
Super stoked to be here. Thank you so much for having me, Paul. So I am currently in Warsaw. This is one of my homes. I have a second home in Sydney, Australia, and I tend to travel between the two depending on the weather. So I kind of divide my time between here and there. And at the moment, I'm in Warsaw.
Excellent. Yeah, I'm stuck here in Virginia with snow and skiing right now. So I don't know if that's a good thing or a bad thing, but Australia this time of year sounds wonderful.
Yeah, no, I love skiing actually because I was growing up in Poland, so it was really easy to find the mountains full of snow with nice slopes. So skiing is actually really fun, I think. So I'm kind of jealous, but yeah, it's nice to have more sun than not throughout the year. And I feel like in terms of the ratio in Poland, it's actually quite tricky. But in Australia, it's almost like reversed. Like most of the year, you have sun, and then there are a few months maybe when it becomes, well, winter is very mild, but and still quite sunny. But yeah, there is more cloudy weather and maybe some rain here and there.
Yeah.
And it's actually, I'm not sure where exactly. Yeah, I think for you it's also like the reverse kind of seasons, because in Sydney right now, while I'm heading there in at end of this month, it's going to be autumn. So it's a little bit of a different, quite reverse cycle, just like in some South American areas, you also have this reverse kind of seasons.
Right. Well, I'm envious, and I hope you enjoy your trip and your journey back or over to Australia. But and again, thank you for being here today. You have I first became aware of your work with large language models and artificial intelligence through one of your books on GPT. AI, GPT-3, I guess it was, technology, and I thought it was really great because it was a great introductory book, but it was also a good book for going into the details of how this all works and how it can apply to enterprise systems. And being from the autonomous vehicle space and robotic space, I and probably others in our industry kind of struggle to figure out. We're struggling. How do we apply this? Is this technology applicable? So I thought it would be great to invite you on the show because you have an extensive background with large language models, their concepts, how they're used practically, and demonstrations and actual applications, and also you do a lot of writing about this, YouTube videos, and a new podcast I hear, as well as a company, Cohere. So you have a lot going on. I don't know if you would like to kind of comment on sort of what else you're doing, or maybe embellish what I've just kind of mentioned, what your primary activities are today.
No, I think it's a great summary. It's a very kind recap of what I'm into. So I did write a kind of a handbook for people that want to use GPT-3 in the context mostly of the OpenAI API, so calling the API system via cloud. But also we dabbled a little bit into the enterprise realm at that time. But at the time we were writing it, GPT-3 was sort of this up-and-coming model, this revolutionary model, the quantum leap in language technology. And enterprises were intrigued, but they were quite cautious when it comes to the implementation. So fast forward 2 years, I guess, or maybe even 3 years, 2 years since the book launch, we know much more when it comes to how these models actually impact the performance of various processes that businesses and workflows that businesses have out there, and kind of what are the struggles in terms of the implementation and so forth. I primarily am exploring this space via my own investigations, talking to people. I love talking to others and just learn in the context of a conversation, just like we are here today. I'm hoping to learn stuff from you as well. And so this is why I created the podcast. So I am working 2 years now at Cohere, where we develop enterprise grade large language models. And I have a fantastic team. We have an extremely talented group of people working on these models, almost 300 of us actually at the moment.
Oh, wow.
Working both on the side of developing the models from scratch, the data, gathering the data for the training, then optimization, implementation, the production, marketing, safety, and so forth. And whenever I have a chance to, especially talk to folks that are closer to the technology side of things, to the customer side of things, I am always fascinated by their insights. And so I decided to just go and investigate and talk to the most curious minds I met so far. So that's what the season 1 of the podcast is about. Actually, if you want to check it out, it's already out there. It's just called the Sandra Kublik podcast, and I'm talking to different experts in the LLM space. All of the experts in this season are women. I also feel like the distribution sort of a female voice in the space is a little bit is to be improved. So my small mission with this podcast is also to help get more airtime for female experts and create this sort of role model for future generations as well. Fingers crossed. That's a very ambitious goal. Yeah, but at here it's really it's fascinating journey to observe. We used to be this kind of startup with great pedigree, because our CEO is actually co-author of the famous paper that introduced the transformer architecture that all of the large language models out there are based on right now.
Okay.
And we have a lot of sort of advisors and board members that are the early kind of pioneers to deep learning and the AI space. We have a very, very smart kind of business investor setup behind us. But I would say the beginnings of developing this technology and finding the product market fit were quite, I don't know if fragile is the right word, but like we were really trying out different things and not sure how to progress forward. Generally, startups were really keen on experimenting with it and moving fast and moving forward with the API. But then we started, after the ChatGPT kind of explosion, we started getting a lot of inbound requests from larger businesses to, well, put it bluntly, create something like ChatGPT, but that is customized to specific use cases and that is secure and sort of tuned to enterprise needs. So we kind of shifted gears and started catering fully to the enterprise customers, and that's what we are focusing on right now. And yeah, this kind of progression, this evolution, even from within the company, was really interesting to observe and very informative in terms of how the market is shaping.
Yeah. Well, I mean, so many things there that I want to dive into. And especially also, can you repeat the name of the podcast? What is it?
So it's just my name and surname,
Okay.
Sandra Kublik podcast. So it's going to be pretty easy to find.
I'll put the link up on the video version of this. And since I have a commute now to work, about an hour, sometimes an hour and a half each day. I'm just absorbing podcasts every day. So this will be one that I'll definitely tune into. But for some of the audience here on this show, there's a lot of autonomous vehicle, some robotics folks. LLMs and GPT AI is a little new, so if you wouldn't mind indulging us for a little bit with just sort of a like kind of a brief description in your own terms. How do you define an LLM, and how does that distinguish itself from GPT and generative AI? Just sort of unpack that, if you wouldn't mind, for the folks here.
Oh yeah, absolutely. So there's a lot of buzz, and it's easy to get lost in the terms, especially when you're kind of trying to follow the media and how they're using this terminology. But so starting from the beginning, large language models are these artificial intelligence machine learning models that use a new type of architecture called transformer that, as I mentioned, one of our co-founders co-created. It's this. It's been sort of creating waves across the NLP industry ever since it was launched. The paper is called "Attention is All You Need," and it kind of details out the
Attention is all you need. Is that what it was called?
Yes.
Oh, that could be like a new Beatles song.
I know. It was a great nuance right there. Actually, when you look at the names of the papers in the NLP space, they're always very playful. So it was a fun thing to discover. But basically, this paper is outlining a new type of architecture. So we're not talking about convolutional neural nets, that sort of stuff. We're talking about the new architecture for models called transformer. And that architecture is specifically useful for data that is sequential. So in that case, language data, where you have words that are kind of that follow one after another and then create bigger entities like sentences. Transformer architecture is excellent at figuring out the meaning, the nuances in between words, the kind of contextual juice in the entire text that you give it to process. And so it created quite a stir in the, I mean, it was the biggest discovery, the biggest kind of invention since I don't even know when, but the paper was launched in 2017, and ever since then, this is the biggest paper.
So what is the transformer? I mean, if in a nutshell, like for people, like what is the architecture and what makes it sort of groundbreaking, different from other neural networks in the past and methodologies, I guess?
Yeah. So basically, what transformers do is they process data kind of in parallel through something called self-attention mechanism, hence the title, Attention is All You Need. And this self-attention mechanism allows to capture, as I mentioned, the relationships between the words, no matter the position of the words in a given sequence. Kind of. And so this allows for a very efficient learning of the information that is kind of embedded in the given data that you give it. And it makes it a much more powerful language understanding tool. So far, we have had models that were perhaps capable of understanding the relationships between words and in a sequence, right? But if you are able to kind of go past that and look at the bigger picture and kind of try to understand the entire map of the given text-based data that you give it to, then you have a very powerful model that is able to answer questions based on this data, that is able to generate similar type of textual data, if that is your wish, that is able to also communicate with you via natural language. And this is particularly something that I think will impact massively the way we interact with language models, with artificial intelligence moving forward. Since we have transformer architecture, we have an architecture that allows us to communicate with the models via natural language. We call it prompt engineering. So prompt engineering is basically creating instructions for the model formulated in a human natural language, in a way that gives the model enough context to be able to perform a task that you ask it for. It could be a question, it could be answering a question, it could be modifying text in any sort of shape or form. It could be going past its initial kind of data set that it has and the sort of information that it has formed from pre-training about the world, and going into tapping into the data that you specifically give it to, or tapping into the web search. And then what happens is you come out with a very kind of language savvy beast that understands human conventions, human communication patterns, and is able to successfully replicate them and kind of engage in a communication with humans that is also kind of very smooth and very pleasant and fun.
I see. So it lends itself to it sounds like mostly text based and language, hence the name. I guess inputs from human beings via prompts. But I've also seen some of these applications to imagery, generating images, but maybe that's still from textual inputs. Is that a different thing from large language models like DALL-E and those architectures, or is it sort of, where does that fit into the taxonomy of how all these methodologies kind of come together?
Yeah, that's a great question. So we have this term called generative AI, which kind of encompasses all kinds of models that generate data.
Okay.
It could be textual data, it could be images, it could be audio data, it could be numbers, like whatever it is, you have it generate something, but they don't necessarily are built in the same way, and they don't necessarily use the same kind of components in terms of the architecture to achieve this result of generating something. And in case of image generation models, the most famous one, I think, is like Stable Diffusion model. So there are kind of elements of the architecture that are even called in the same way. So for example, GPT type of architecture uses something called encoders and decoders. You have the same elements in Stable Diffusion that use encoders and decoders, but they don't really use self-attention mechanism that I just described. That kind of self-attention mechanism is really optimized for words. So it really kind of is able to focus at specific words and the relationships between them. Whereas in image generation, the way to process large amounts of images and being able to understand the patterns there, it doesn't really work in the same way. And it's also not the sequential kind of type of data imagery. It also generates stuff. So and it also uses a lot of data. So they're also large, these models, large and powerful. They also came about around the same time into the space, and therefore we have this kind of umbrella term called generative AI. But fundamentally, they differ quite a lot. At Cohere, actually, we made this fundamental choice of focusing only on textual data in order to kind of nail it really well, because a lot of the human tasks are related to language. And there's a lot to learn in the sense of creating the interface, in the sense of tuning these models to specific use cases. And so we wanted to focus our attention, human attention there, rather than exploring the image generation area. But it's also very, very exciting, super fast moving area with a huge open source community. That's also something that these models have in common. There is this famous AI race right now who has the most powerful, most savvy, most universal kind of model. And so in terms of the kind of market trajectory, I would say there are a lot of similarities, but fundamentally, yeah, the architecture is different.
Interesting. So now, but inherently, underneath all of this, inside the architecture of these systems, there's obviously deep learning neural networks, right? Neuron models, and how they're connected, activation functions, and all the things that constitute a neural network. Are there any other things besides, like, I guess, or what are some of the other things, if there are anything that sort of the magic, this secret sauce, if you will, behind making these models do what they do? Is it just how you connect neurons and how you train them, or is there some other sort of supervising functions that really give it the power that they now have, that maybe just other neural networks that preceded them did not have?
Yeah, that's a great question. So there's more to that, of course. So architecture is just one of the components. Second component that is just as key for the magic to happen is the data, the training data that you give it to. So it was very fortunate for transformer architecture to kind of coincide with us being able to train bigger and bigger models, and kind of the increase of compute available at our hands in terms of the hardware advancements as well, allowed us to explore bigger architectures.
So like more neurons,
more neurons, just scaling what we already have. And,
okay.
And this is something that actually OpenAI guys noticed looking at, before GPT-3, there was GPT-2, GPT-1, and they were really interested in the question of, if you scale the same architecture that seems to have these interesting capabilities, do new capabilities emerge in the models? And it turned out that yes, indeed, that they did emerge. And so so for scaling, you need a lot of compute, but you also need a huge amount of data, and also the right amount of data. So that's why training data is a huge component. The first models out there were primarily based off text scraped from the entire internet. So it was quite a mess, to be entirely honest. And it quickly turned out that models also tend to learn biases that are kind of embedded in the data that you give it to, and they tend to amplify the biases in the outputs. So let's say if you give it 95% of clean, polite, politically correct data and so forth, and then there's 5% that is skewed towards, some xenophobic, racist, whatnot, narrative, the model will actually tap into this narrative, and it will kind of start to amplify, and it will kind of poison, so to speak, its voice, so that the outputs quickly become predominantly in line with this type of discourse. So training that data has a huge impact on the model capabilities. And initially we just needed a lot of data, so we scraped everything, and now we're much more kind of choosy when it comes to the quality of the data. And we also have this data coming from people interacting with the models and expecting certain behaviors, and we use that data post kind of training to fine-tune the model behavior towards the way we want. So I would say we have the architecture, we have this number of parameters that's huge, we have the training data. We also have something called optimization algorithm. Most of the time it's stochastic gradient descent, if I'm not mistaken. So it's a reinforcement learning algorithm that is also used in the large language model. I'm not that familiar with that one, but I know this one is used in order to optimize. And then once the model has already been initially trained, hence the sort of generative pre-trained transformer. So once it has been pre-trained, then you want to fine-tune it on data that comes from a specific domain, and also perhaps formats of the certain conventions, human communication conventions that you wanted to know specifically, or just as I mentioned, just like making sure that the model is the best, most polite version of itself, and you can almost kind of ask it to be a certain way and to follow certain values, and be respectful towards the user and so forth. So that kind of magic, this kind of taming the model once it's been pre-trained, happens in the fine-tuning stage.
I see. So yeah, and it's interesting that the politeness aspect of it probably relates to certain applications of this technology versus if you're trying to generate code, software code, or to create things, or other generative AI. I mean, code might be to program a robot, might be to program something. So I guess that's a different. You're giving it obviously different inputs than, and probably have a different training mission, if you will, when you depending on the application.
Exactly. So let's just think of an example. You want to create a very savvy chatbot, but you want it to be kind of moving comfortably in the finance lingo, or medical lingo, or lawyer law lingo, and specific type of law, because there are plenty, of course. So you create a data set that has examples of this specific language and specific model behavior that you want the model to kind of later on showcase while it's interacting with the user in an application. And this data is kind of used in the fine-tuning process with a mechanism called transfer learning. The model, the transfer learning basically helps the model to adapt to these task-specific data, that you give it, and perform well in more specialized circumstances. So perform well in the context of giving financial advice, thinking about kind of specific offer, or specific specialization in terms of the medical applications, or specific codex in terms of law. So you really, initially, you want the model to have sort of a general understanding of the world and of human conventions and so forth. But later on in the fine-tuning stage, you want it to really go deeper and kind of become the specialist of a certain domain.
Yeah. Well, interesting. I guess so I think it was in there somewhere, but I just want to just sort of draw it out just to make sure I'm clear before we move on to this next topic. So LLM versus GPT, compare and contrast. What would be the difference?
Yeah, so GPT, generative pre-trained transformer, is the most common architecture in the large language model space. So we have large language models. These are the models that are, all of them, most of them, use transformer architecture in order to perform a certain array of tasks. GPT is the most common architecture for generative models, the models that you usually ask to generate new type of data, modify the data that you gave it to begin with. But there are also other architectures. For example, another very common architecture is called BERT, and the BERT architecture is being used is the basis for the embedding models. So we have models that generate text, but we also have models that represent text in a way that is very easy for the machine to understand. So embedding models are models that take the textual input and then embed it in a vector space to create a representation of it, a kind of numeric representation for your model to kind of move freely around it. And you typically store these vector representations in a tool called vector database, and then from there you can have, for example, two models, generative model and embedding model, and they can work in tandem in a chatbot application where the generative model takes the input from the user, looks for the information in the embedded text that was embedded by the embedding model, and then kind of retrieve this information back to formulate the response for the user that includes the information. So embeddings are really useful for creating a search system that we call it a semantic search. It's the new type of search system that so the most common search system that we can think of is keyword search, right? Like when you're typing something in your computer, trying to dig out the information, it will retrieve the information based off of the keywords that you give it. What semantic search does with large language models, their kind of next level search performance that it gives, is it, just like the generative model, it understands the relationships between the words, it understands the document from the sort of bigger picture, and it's able to much more precisely match the user expectation. So let's say my colleague uses this example. When you're typing into the search bar, American Australian visa, right? So you type it, and then among the results, you will have Australian American visa, you will have American Australian visa, and then you will have a bunch of just like things that are like further related from the topic. But it will give you sort of this this entire cloud of possibilities related to the keywords that were used in the search. In semantic search, what you have is the result that matches the exact kind of Australian American visa and understands the relationship, understands that it's not the other way around, that you mean it a certain way, you mean it from Australia to America, or the other way around, if that's what you want, and is able to give you to this result more precisely. So this is also what large language models do. Very few people know about it, really, because ChatGPT blew up and kind of it's very easy to intuitively understand and want to interact with the text generation model. But we also have these beasts called text representation models based off of embedding models that also belong to the family of large language models.
I see. Interesting. So, and well, you mentioned one of the things that's making all this, grow and possible now is adding more neurons, which means more hardware. Can you kind of characterize in any way what, if you're able to kind of comment on, for a typical sort of say enterprise application, which I want to talk more about what those are, but for a typical enterprise application where they're going to have their own maybe private hosted, and I want to talk about that, generative AI engine. What kind of hardware is needed for this? Is it just a computer with some GPUs, or do you need racks and racks and racks upon of computers that fill a room? maybe it's all of the above, but what do you need, I guess?
So the good news is, like, once you have the powerful architecture, you can actually make it work on a bunch of GPUs. To the exact numbers keep changing, so I encourage you, depending on when you're listening to it, just go and check out what's the current benchmark. But yeah, you need a bunch of GPUs. There are people that are like kind of like trying to because we have this open source movement right now, right? So there are large language model architectures that are available open source on spaces like Hugging Face, where you're able to kind of grab the architecture and then try to improve it and train the model locally on your machine. And as far as I understand, what you need is just like a very, very robust computer, the gaming type of computer.
Just a gaming computer, yeah.
Yeah.
Well, that's amazing. I mean, that to me is a, no pun intended, game changer, because that sort of democratizes use of this technology, right? Enables people to create applications and do things at a much more innovative scale, I guess, because you have so many different people trying so many different things, and that's interesting.
I know it's one of the fascinating areas. I saw this tweet recently by an NLP researcher that LLMs are a really weird space where you have people that have like spent many years doing PhDs and are in the labs, specialized labs for this, trying to come up with the latest, most kind of robust architecture. But you also have folks that are just experimenting with it, that are just really inspired and are have developer experience in the past, but definitely not the kind of scientific background behind it, that are also contributing to the research and to the innovation and pushing kind of the envelope. So it's I think it's a fascinating movement, and also makes me really hopeful in terms of the progress, because once you have access made so easy, it's really I mean, both bad things can happen, but predominantly I think the we can expect very, very, very many positive innovations coming out of it. So at Cohere, but you also have these proprietary kind of models like OpenAI, Cohere, Anthropic, and so what we do at Cohere is we are training these very robust models, and then you are able to use them locally on your machine so that they have kind of no connection with us. We kind of package them and send it to you so that you can use it on your own premises. And there are plenty of benefits related to that as well. So first of all, it's also about safety. You kind of want to make sure that your model is not going to surprise you in terms of its behavior once it starts to interact with the data that you have and out there in the world. So you really want to use a setup that has a certain standard of safety and has been kind of made bulletproof of close to by the researchers that know how to make the model immune to a certain way of hijacking, hacking, prompt injections, and so forth, because there's plenty of that type of behavior out there at the moment. And also, again, like, you are able to push the model a certain way. You are able to like use smaller architecture, smaller number of parameters, and achieve great results. But we kind of specialize at making it better and at implementing the latest kind of techniques that allow to make the use of the model very efficient, save up your costs when it comes to the hardware, and also keep it up to date all the time in terms of capabilities. This field is moving super fast. So if you spend a lot of time using an open source architecture that has a certain, let's say, it's really great, but only in English. But then suddenly the field is making the advancements, and you now have models that are super sufficient, super not sufficient, expert. Expert in 100 languages out there. So then you want to be able, perhaps, if your application, of course, requires or would benefit from it, you want to be able to use that type of model. And when you use proprietary models, you kind of have this guarantee that you're using the models that are the most robust with the latest capabilities and are able to do all these crazy things that you hear about in the news, rather than you kind of get static with a certain version.
So that's interesting. I mean, there's this classic, well, I don't know how classic it is, but there's a well-known sort of question and paradigm shift at one point from well, I guess that the question is to host or to not host. Do I host it on a third-party cloud server, or do I host it locally? And obviously there's pros and cons of each. There was a big shift towards, of course, hosting servers from Amazon and other providers all over the world. With security guaranteed for your email and whatever else, your websites that you were hosting. And of course, there have been some high-profile security breaches over the years. And this kind of information, though, that you're putting into these generative AI engines, if you will, or that you're using to train them, can be, the company's most critical trade secrets. It could be your IP, your code, it might be much more than just information for creating a chat bot, which might be proprietary, but just very critical intellectual property that if it gets out there, you're done. The company's over, right? So it's very interesting that, I guess, with Cohere that you support or provide this capability to have your own private instance, your private hosted instance. You package up, it sounds like something, but then there's the con of that. Even with hosting is the update model, like keeping it up to date. So how do you? That's interesting that you address that problem. How do you provide updates to the model for these enterprise clients that are using these instances that you're providing?
Yeah, that's a great question. So just to be clear, there are a bunch of options here. You can have access to Cohere models via any cloud provider via VMs, right? So you can have kind of like you can use their cloud setup in a more kind of secure way to be able to use it that way. But you can also deploy them locally, as you mentioned, in a way that does not kind of communicate with any other
I see. Party. So you do both. Okay.
We do both, and the way we do it is we keep working on models continuously, so it doesn't really stop for us. That's what we specialize in. But at a certain point in time, once we are satisfied with a certain version, we freeze it, and then we kind of make it available to our cloud partners so that people can use it that way, or we package a certain version and then ship it. And then whenever there's an update, we do an update, but there are periods of time where you are using a certain version and then go into the next version while we keep working on a given model.
I've never thought of version control with respect to neural networks, to be honest. I've just never thought of it. So like, do they have to retrain? Like if they've trained some of their data, train the model that they had from version 1 that you've provided, or say you have version 1 of a model, and then you train that system with some of your own data, and then you get a new model architecture update or something. Do you have to go through the whole process of retraining it with your data again, or is there a way to kind of merge the models? Or it might be difficult to do, but I'm just wondering how that would work.
Yeah, I'm not sure what are the specific solutions when it comes to the version control. I know that what we do is we make sure whenever we release a new version that it's going to be compatible with your setup so that you're not going to run into weird errors. But I also know that it's relatively easy once you have a certain data set for fine tuning, which doesn't have to be large. It's literally, we're talking about hundreds of examples of something. So it's a relatively small data set, and it doesn't really cost that much to fine tune your model to a specific use case. I think you can quite easily replicate that with a new version. And also the benefit of that is that with fine tuning, you really can keep iterating and adding new data on top of what you already have, so that it keeps being relevant, and it keeps improving over time.
Interesting. So I guess what are some of the enterprise use cases and applications that you see are the most compelling and appropriate for this? And maybe there's many, but what are your like top 10 or 3?
Yeah. So I really love the topic of use cases. I really enjoy seeing the models out there in the world and making something happen. So actually, I would say the most common use case that we see across the board when it comes to enterprise implementations is a sort of internal chatbot system. So you have and it's also a great use case to start from, even when you're thinking about building LLMs into a setup that gets in touch with a customer, for example. Like it's really great to start with a use case where you have a model that is accessible. You have a chatbot system, let's say, that is accessible only to your employees, only within the kind of scope of the company data. It has access to all these different data sets. So I don't know what you're using. Could be Google Drive, could be something else, could be Gmail, could be Slack, whatnot. Companies have really all sorts of setups, but it has access to all these repositories of information about your company, and is available for your employees to kind of search for information on a daily basis. We need certain information about policy, about how things work, about who is responsible over what are the rules for this and that. And so at Cohere, we actually have a model. We have a version of that implemented and has access to our wiki, and we can, interrogate it. I do it very often when it comes to the, HR policy, when it comes to looking for, especially when it comes to like when you have a growing organization, you have a lot of new people coming and a lot of kind of new teams being formed. So it also helps me to navigate that kind of dynamic landscape.
That's interesting. So you point it to your your wiki, and it just you've created some interface, or does it just kind of go through every web page and use that as is it an automated way to kind of ingest all the data from your wiki?
Yeah, so it depends. If the data is dynamic, you want the model to be able to kind of access it every time and search through it. So we actually have, this is kind of one of the latest features that we're working on, called connectors. Our model is really trained on the chat type of use case, where whenever user asks about certain information that is outside of the model's internal kind of knowledge system, it's going to connect with the source of data that possesses that type of information, and then retrieve it from there. So it could be, I think we've built example like 80 connectors to different systems like Slack, Jira, Google Drive, whatnot, Zoom, whatever, wherever you're using their Notion. We use Notion a lot for company wiki. And then you also are able to create your own connectors. So if there's some sort of API that we haven't covered yet, you are able to kind of create a custom connector with the system that you're using, and then the model will kind of go and search for the information there.
And is this supervised where human beings sort of help filter out what might be like old data in the wiki? Wikis can have, outdated information or conflicting information. Is it supervised with humans, or is it, or do you have way, or is there some way to kind of tell it, only look at things that's, within a certain date range or something to keep it fresh?
Yeah, so the type of wiki that we're using, we kind of keep it up to date, and we archive or remove older versions. So the model doesn't really have access to that one. But the cool thing about the way we built the model is that whenever it's called retrieval augmented generation with citations, where the model is venturing out to particular database, it's retrieving that information, it's using it to generate the response for you that includes the answer to your question, and then it quotes, creates a reference for the source of this information, where you're able to go to a particular link and verify whether this information is actually there, and also what source of data it is. Is it up to date? Does it look legit? Is it something that I can confidently use moving forward? So that's how we kind of make sure that the answer that the model provides is trusted or is verifiable, so that you're able to actually go and check whether the response satisfies your needs, and you can trust the source.
Interesting. So, well, that's fascinating. I love the idea of, of course, there are going to be many enterprise customers who want to use the cloud or hosted solution, but I can certainly speak to interests from I guess my own sort of perspective, and some others maybe who'd be interested in putting code into these systems, and being able to ask it to code and other sorts of data, to be able to ask it to generate new code based on libraries that a company may have, such that it can create, basically build upon a software library that a company may have, a framework or something that a company may have created to just create new behaviors and what have you based on existing code. So that's one of the reasons why I find that. Have you seen any applications like that, or have applied your technology to those types of applications with code as the input?
Yeah, I've seen code applications, code generation applications out there, definitely. We are going to come up with very exciting updates in that domain this year. I'm not sure when this podcast is going to be out, but we are still working on it, and we are like 2 months away from a major update in the code generation. Because this is a use case that we're getting asked about a lot. So how can I kind of make the job of my engineers easier? How can I give them a tool that will help them organize things, troubleshoot things, and also perhaps amplify the work that they've already done? This is something that we are working on. In terms of just like demos out there or implementations out there for large language models, I've seen a ton of them. I mean, the most famous example is GitHub Copilot. So this coding assistant that, well, here's the first fascinating thing. Because the models speak our language, we're really able to communicate with them in our language to have certain code effects happen. So you have a GitHub Copilot where myself, I'm a very basic coder. Like, it's really not something that I shine at. I'm much more of a human language communicator rather than coder. But I am able to communicate with human language, a certain vision for an application, for a game, for whatever you want. That will have this assistant go and execute this code in a way that I'm able to then run this game, package it into an app, and have it launch it on App Store, whatever.
Yeah.
This is crazy. But yeah, so GitHub Copilot. If you haven't interacted with it, I really encourage you to check it out. A lot of coders out there are already using it for their daily work. And so basically it helps them to perform the basic coding tasks with the kind of general supervision of the coder. But it also helps them to translate one code from one language to another, or come up with multiple solutions to a certain idea that you have. It's really fascinating. It's really kind of next level code generation assistant that you have at your hands right now. So it's out there. Yeah.
Interesting. I've heard of GitHub Copilot, but I personally myself have not taken a gander. So I have to look at that. So other enterprise applications, you kind of talked about the internal, I don't know if it's like a chat service or internal agent, if you will, to answer company questions. Any other kind of big enterprise applications that are becoming more, or will become more popular as the capabilities grow here?
Yeah, so we also see a lot of success with re-ranking models. So re-ranking model is a type of embedding model that is helping to kind of infuse your existing search system with the large language model semantic search capabilities, and is helping you to retrieve information in a more efficient way. So if you already have a certain search system in your company, but the kind of level of success is so the results don't really always match the user's intent, then you can infuse this type of search with semantic search capabilities, create a sort of hybrid search. I'm using a lot of kind of lingo from my world, but then you can go and look for, there's so many good materials on creating a demo application of that and creating a hybrid system. So classical keywords search with semantic search, and then you're able to actually have the re-ranker do a search on the basis of the results retrieved by your keyword search system and output the better suited information that you're looking for. So this is something that's very, very popular right now that we see.
Yeah. We as a company don't have, we haven't sort of agreed to one unified platform for everything. So, we might have Google Mail, Slack. We have a tool called Teamwork. So we might use Jira, all these different tools, right? And so all of our information can be spread across these different tools, and you have people searching different tools. And I know there are some tools out there that claim to kind of bridge all of that and make it easy to search across these different third-party tools. And we've had limited success with those. But maybe this like I guess you would still need those connectors to kind of get the data from those different tools. But it'd be nice to have sort of a unified, more intelligent search system for getting data from all of your different enterprise data sources.
Yes, so this is actually something, again, a scenario that you described, that's something that we hear very common, and we listen to this. And so connectors is kind of the first step in that direction. It's like the way to very easily get in touch with a certain database that your company is using. But then, as you mentioned, there are different types of data sources that might be needed in order to answer a particular question. And so right now, this is technically feasible, that you can create a chatbot kind of agent that has connectors and is in touch with these databases, and then uses, before it generates the response that has the answer, it uses re-ranking on top of all the results retrieved from all these different systems, and outputs the most kind of the best suited to user intention output. So that's technically feasible, but you can expect this year updates on our end that will make it easier for you to create a setup like this without having to do kind of like a custom scenario.
Well, that would be fantastic. I can't tell you. I mean, there's as you know, there'll be some information in email. There'll be some information in a Slack conversation, information in this tool, maybe on G Drive or whatever that you're using, and to be able to kind of stitch together an answer based on these disparate, heterogeneous sources of information within the organization would be fantastic, because we just do that manually. Oh, I think I remember this email that so and so sent, and then I'll search for it, and then the search isn't great for that tool, and you search in Slack, and it's it's okay, and they're all getting better independently, but yeah, nothing is sort of also connecting them all together. And so that would be there's a to me a killer app. That kind of really intelligent search for the enterprise. I mean, it's fascinating. I mean, sounds like a great business model. I'm very, as you could tell, interested in the code generation aspect of all this, but then all of these other things that would make one more productive within the enterprise, within an organization is just fantastic. I mean, so what are your predictions and expectations along these lines for the next big development in all of this in GPT and LLMs? I mean, we kind of talked about, some interesting things, but what's if you've given it any thought to what's the next big thing, if it be it a new architecture change or a new application that's just going to make this really go to the next level?
Yeah, that's a great question. So, I mean, it's not only about architecture; it's also about the hardware that is available and all that. So it's all kind of like it's this entire ecosystem moving forward. That makes it really hard to predict what the next big leap will be. But in terms of the next few years, I think we haven't capped out when it comes to the potential of transformer architecture. I think there will be much more innovation in that area, where you will have perhaps smaller models but more nimble and more kind of efficiently using your hardware cost efficiently and compute efficiently, using the hardware to perform tasks at a similar level as this big general but a little bit clunky model can do at the moment. So I think we will see a lot of cool smaller models. We are already seeing, and models that are tuned to a specific use case. Code generation is one example, but there are other ones. We also will see models that are better performing in variety of languages and have a better kind of cultural understanding that is more kind of global understanding rather than based off of the English speaking culture. The differences are quite stark. I myself am natively Polish, and so there was quite a lot of Polish language being used in the most common large language models out there, so they are performing quite well. But there are also these languages that don't really have such a great coverage, or the nature of them makes it really hard for the current models that are not kind of used to the structure, like Arabic or like Asian languages, that have completely different kind of pictorial systems. The models can be quite choppy when it comes to them. So I think we're going to move in the direction of being kind of more global, perhaps having a model that is performing really well in a family of languages with the understanding of kind of different cultures and being really savvy when it comes to the language structures.
That makes perfect sense. I mean, just to comment on that, because if you look at the history of other industries, similar compute, that there was big centralized compute systems in the 60s and then even into the 70s, and then you had the personal computing revolution, right, where now people could have computers in the home, and then you had more regional and personal variation across the globe and applications that people would develop and might want, and so that sort of, again, just sort of making these models more suitable to run on gaming computers and things that are more accessible, and making it more accessible for people. There's going to be much more innovation, and then you will have these regional things that are more regionally useful for people, because it's tailored for their culture, their language, their things that they're interested in, right? And but then also individually people can create their own sort of personal agents to do what it is that they want it to do for them. And I think that's exciting. I mean, if that technology from the open source community and even from these commercial source solutions that you mentioned become more accessible and more prolific, I think you're right. I think that's going to be we're going to see an explosion of innovation and applications here in the next couple of years, which would be really, really exciting.
Yes, yes. I know it's not as a sexy answer as saying that there will be the next model that will hit the AGI level, which might be might be the case very well. But from my perspective and kind of the usage perspective, I think these are more important kind of leaps that we can already make with the existing architecture advancements. It made me also think your comment of the generational changes that are coming. I feel like at the time the internet happened, and I think we already, between us, there's a difference in the sense of you started using internet, personal computers, all that tooling as an adult with like formed cognitive capabilities. So you have a different attitude to it than myself, that I was growing up with them. I was growing up on chats, on different forums, nerding out on different topics. So I think it's fair to say that something similar is going to happen with the models. So we will have these interfaces that have assistants that are much more savvy in terms of being able to manipulate the information that we give it. And we also will have these assistants that accumulate our history of conversations over time. And I can imagine big changes happening with the generations that are now at school learning things and just having access to an assistant like this and being able to ask it certain questions that perhaps teacher doesn't have time to answer because they have to look after the entire class of students rather than one individual question and one individual curiosity. But then they can like really dig deeper with an assistant like this. And then on top of that, also this type of assistant will have it's going to be really fun to interact with. It can really be stimulating for users to being asked questions based off of the information that they're interested in, or being told a story, or just I can tell you that when I'm even when I'm just surveying my friends in terms of how they're using ChatGPT and other personal assistants like this, each of us has a different version of that. Some of them are really when you like, I personally because I'm not native to the ML space. I come from philosophy background, so I have a lot of questions about like definitions, the kind of fundamental questions about things. And so I am using my personal assistants to help me explain these more fundamental definitions for things. There are people that are using them to kind of design their travel itinerary in a particular area of the world. There are people that are maybe asking about similar category, but in a very different way, just like trying to use allegories or things like that. It's really fascinating. It's going to be really fascinating to observe what is going to happen once these new kind of cognitive capabilities of the models will start to impact and co-shape kind of the upcoming cognitive capabilities of our generations. I think it's going to be very transformational for us.
And I'm with you on that. Like, you and I both kind of think of the utilitarian, the useful aspects or applications of this technology. One of my board members is Nolan Bushnell, the guy who founded Atari, and he comes from a background where he speaks of the entertainment applications of things. We'll talk about robots, and I'll always be, I want the robot to bring me something or do something for me, and I've really started to understand his philosophy much better, of course, in that a lot of people like to be entertained, and so to that end, what are going to be the entertaining applications, the entertainment oriented applications, and the gaming applications of this technology? What's going to be the intersection there? And will there be pushback, right? Because some people who create those entertainment some people who create the entertainment content will not want the machines creating this entertainment content, and it may be derivative. But I'm just wondering, have you thought of or explored any of the entertainment-oriented applications of this technology?
Yes, I love entertainment industry. I'm a creator myself, so I'm following it closely. Some of the coolest things I've seen is, for example, giving one of our community ambassadors at Cohere has used our generative model command to power the NPC interactions in a given game. So it could be Cyberpunk or whatever game you choose. He created a demo app that was able to plug into certain game and let you kind of make certain moves in that game, come closer to an NPC that normally would have, a one-liner, two-liner, and that would be it. And then have an actual conversation with them, where they have a personality, they're able to actually have a creative conversation. So you really have more of an immersive experience in a game rather than this kind of one design scenario. So that's a really cool area, and it makes total sense for me that gaming companies are going to start using generative models to create dialogue, just because it's time consuming and it's costly to create a character for every single element in every single character in a given plot. But now you are able to give it much more kind of color with large language models, and it's going to be easier and cheaper as well to do something like this. So
that's fantastic.
Yes, you can.
That's a great idea.
Sorry, go ahead.
I was just saying that's a great idea, and I think it's going to be not predictable too, which is great, because no one interaction, no two interactions will be the same, and that's a great application.
Yeah, I also seen applications where in gaming, I'm gonna move to other ones after this, but in gaming still, I've seen some really cool examples of games that sort of adjust to where the plot adjusts to your choices. So you start from a specific vantage point, but then you give it a certain direction based off of your particular mood or whatever whatever entertains you most at any given moment when you enter the game. And then you have a completely new, storyline, completely new adventure based off of the script that is generated by the model, and perhaps image generation models that are also being able to kind of make the elements of the game adjust to that script. I think this, I've seen this, and I think this is going to be something that is going to become more common soon. So that's on the gaming side. Now,
just what real quick with that, with respect to that, there was, and I'm going to date myself here, but I used to play these interactive fiction games, these games from this company called Infocom. They were called Zork, and of course they had Hitchhiker's Guide to the Galaxy and in this interactive fiction form, and you would type in sort of just English style sentences as to what to do next. Go here, look at this forest, and do this, do that. It was much richer interaction than just simple, up, down, left, right, look left, look right type commands. You would type sentences, and it would give you interesting responses. And it was an interactive book, and of course that, with GPT could just be infinite. I mean, there's just an infinite number of possibilities there, and I think that's fascinating as well. That's really interesting.
Yes, so we are kind of the co-creator of the entire experience, because we have so much input, right? It's not only when you're reading a book or when you're starting a game, it's not only you follow a certain path that was thought through for you before, but you're actually giving your input and co-shaping the entire experience. I think it's going to be mind-blowing. So yeah, so these kind of text-based adventure games, they already have the flair of large language models. You can check out, for example, AI Dungeon. It's one of the most famous ones, where you are
AI
able
Dungeon,
yeah, when you're able to play Dungeons and Dragons, but also many different other scenarios, and you go along with the text, and you decide what's going to happen next.
Interesting.
Yeah. So that's one. Another one I've seen is, I think, creating avatars as a sort of more 3D experience to any kind of narrative, any kind of creative narrative, any kind of creative brand will become something that is going to be very common. First of all, we are better and better at generating images. So here, the image generation and text generation models will go in tandem. With text generation, what these models provide is the personality. They're able to follow a certain personality once you are able to specify it. So let's say we have a children's story, and there is a character in that story, right? And it has a certain personality, it has certain characteristics. It's like anxious, it likes sweets a lot, and it likes to and it likes to hang out with friends, right? So you can take these characteristics, ask the model to create a character that is going to speak the same language, that is going to exhibit the same personality as that particular character from the book, but have it interact with the fans of the story and of that character. So let's say, think of any Disney story, any Disney princess. The Disney princess can now interact with the fans and is able to answer specific questions and is able to give, very custom personalized experience to children that are fans, because it has this powerful engine behind it, where it's able to generate responses on the fly based off of very specified kind of personality and character.
It's going to be a new world. It's exciting, and I mean, and of course, you and I are both sort of talking about these very positive things and uses, but on the flip side, in some circles, you hear people, and this has of course happened throughout history, right? Whenever there's a new technology, there's people who see the potential dangers and hazards of it, and there's some, even the likes of Elon Musk, of no less, says this is potentially very dangerous technology, and it's worse than nuclear war, and I've been trying, I've scratched my head a little bit, and I've tried to think, why is this so, why are people saying this is like so potentially dangerous? What are the hazards? And the thing I could think of is, and I want to hear obviously what you have to say, but is that when you connect this to things that can affect the real world, if you connect it to something that can be a weapon of some sort, now you've created a link that could lead to some very hazardous and dangerous situation. Of course, the simple answer is don't create those links, just, but that's easier said than done. Governments are going to do what they want to do, regardless of what individuals want. And but then there's the concept of fail safe, always built in the capability to shut down systems and monitor, use artificial intelligence to detect hazards and shut things down, in parallel if you can. But and I know some people are, of course, afraid of the fact that it also generates concepts and ideas that foster, conflict amongst people and resentment and what have you. What are your thoughts? What is this massive, world-ending danger that some people speak of, and what can be done to mitigate it?
Yeah, it's a huge topic. I love that you're diving there with me today. So first of all, there are different levels of safety issues when it comes to large language models. And even among the experts working on AI safety, there are those that focus more on the sort of bigger existential risks related to bioweapon design, things like that.
Right.
And they're the ones that are more kind of hands-on and thinking about not the future things that we should worry about, but the current most kind of most apparent dangers that we can infer from the capabilities that the models have. So I can speak about both, but I think that the most kind of pressing thing that we are facing with LLMs is misinformation. Yeah. So think about it, that you have this new tool that is able to process information in such an efficient, fast, and completely kind of new quality way, and you distribute it across the entire population. If you're not careful, you are giving a tool in the hands of people that are going to do all sorts of things with it, right? And then can you stop them from doing that or not once you give them that tool? So an example thing would be bad actors choosing to use large language models to create very quickly and cost efficiently social media posts that form misinformation campaigns, and then create hundreds of bots that then go out and, using different personalities, different tone of voice, different kind of arguments, flood particular internet areas, particular social media platforms with a specific point of view, and then drown the actual real people's opinions in this kind of sea of a particular view. I have a real world example that I've seen once the Russian aggression towards Ukraine started. in Poland, we started seeing instances of increased bot activity on Instagram and other social media networks, where these bots were accounts that were propagating negative sentiment among Polish community towards Ukrainian refugees, using all sorts of arguments to kind of justify it. So some Polish startups were observing the space and they were able to track the social media activity and then flag it to Instagram. But think about how many of these things are happening on a daily basis that we don't really know, just because we are not looking there. So that's really terrifying, and that's something that is happening already. So we really need to be careful in terms of kind of the use cases that people use. Typically, large language model companies have very kind of strict, very refined framework of evaluating the types of use cases that they allow with the model. But then you also have, the kind of darker side of the open source, where anybody now can take the LLM architecture, run it on their machine, and then actually benefit from the capabilities. And how do you stop that, right? Like this is something that is going to be a problem, and we really need to figure out ways in which we are able to discern AI generated content from human generated content in a more kind of savvy way.
That's an interesting and difficult predicament, obviously, because there's going to be malicious actors, and they're going to do things and purposely say something that is misleading. And then, but at any one time in human history, we're all conveying misinformation because we don't know everything, right? And I'm not talking about that in particular, but like, at one point in history, we thought this remedy, like there was remedies back in the 1900s, right, where it was gonna cure your cold, and it was exasperating the issue, and it's just as humanity learns more, we learn more. So at any point in time, any one of us is conveying information because there's stuff that we've yet to discover. And I'm thinking kind of more scientifically maybe, but there's things that we haven't discovered, and we're just relying on certain assumptions that will be proven false 5, 10, 20, 100, 1,000 years from now, right? And there's going to be new things that we discover. So I've always thought, I think of in terms of robotics and fail-safe systems. You have a system that's doing something, but then you have to have what we call a watchdog, a monitoring system that's sort of watching this system over here and discovering anomalies, and maybe and in the case of a vehicle or a robot, failing safe, which means applying the brakes and stopping. But maybe in this application you would have, can we create generative AI that's monitoring these systems and sort of telling us, hey, this might, have you thought of this? There's 5 other possibilities or 100 other possibilities around what this, this particular person is saying. It's almost like with X, they now have community notes, I guess, right, where people go in and sort of comment on things that may be false. But can we create AI that's checking the AI, if you will, to kind of call out potential and probabilistic potential things that may be incorrect information now, and has, in other words, sick the AI on the AI, make them check each other.
I think we'll have to. I don't know if it takes large language models to do that, but it might very well take large language models to supervise other large language models and flag the behavior that is rendered toxic or harmful or non-factual in a particular context that matters.
Because it might not always be black and white. Some things are more, that's bad and this is good. But where there's gray areas too, it might be good to have these things say, hey, here's some other considerations. Have you thought, and like really, so that's in a way mind expanding. It's sort of giving people more things to think about, right, to consider. That and in many ways this AI can make us all smarter and more richer, because it's pulling the right information and giving it to us at the right time to counter information that may be incorrect.
Yeah, that would be a fantastic application, actually, to have something like this, like a language model with RAG capabilities that is assisting you while you're writing your tweets, and whenever it detects a certain kind of messaging where it can provide a broader, richer context for you, it can pull out this information right in front of you for you to consider before you actually decide to, post or change the way you're framing a certain.
Oh yeah, even as the individual is posting. But I'm also thinking of them. There are going to be malicious actors. There are going to be malicious people. I think 99.999% of the people in the world are hopefully not malicious. Otherwise we wouldn't be living as a civilization. But yeah, there's going to be this malicious group within government or outside of government, wherever they may be, and yeah, to have that sort of that in a way, it's your personal guardian angel, right? To kind of monitor what's going on for you, and maybe it's tailored for what you want to hear, or not want to hear, or some people have higher tolerance levels than others for certain things, right? And maybe it comes back to regional things as well. There might be things in a region where it's more important to those people to highlight, because there's more of an imminent danger wherever they are, right? That's relevant to them, be it at a very local city level or a state level or a country level, that these guardian angel AIs, if you will, can help us with. Maybe that's just my optimistic.
No, absolutely, but
view.
It's like technically it's feasible. Like you have the capabilities in the language models there to do something like this, but then it also comes down to kind of commercial decisions of given platforms and UX decisions as well, because it's not only about information, it's also about how you kind of provide it to people, and that is more on the product side than on the technology side itself. But I would love for us to not only have kind of malicious bots out there, but also the angel bots that help you.
It's the perennial battle. It's
counterbalance. Yeah.
It's existed since the beginning of time. Well, this is interesting. We've talked about so much, and we've talked about Cohere as well, and I wanted to. You have a toolkit too called RAG, is the acronym. All of us engineers, we have to have acronyms for everything, but this is a good one: Retrieval Augmented Generation Toolkit. So what is that exactly?
Yeah, so actually, even referring back to the conversation we just had about the kind of us as humans constantly producing some sort of misinformation just because of the limited context that we have at our hands at any given point in history, in time, and then later figuring out that this is actually the picture is incomplete, or it could be completely false. So RAG is basically this idea that you can improve the large language model access to information, to real-time information, or to information from a particular domain that resides outside of its kind of pre-training data set, in a way that gives the model a real-time access to external data and to external tooling that it can use to interact with you. So we have this endpoint called chat, basically just chat. And it has a RAG capabilities where there are 3 different modes. It can either, we've kind of built it already so that once you say it that you want it, it can ground all your conversation in web search outputs. So you are going to ask it, hey, I'm looking for recipes ideas for a healthy breakfast today, and it's going to come up with recipes, but it's also going to link to the web search results that it's retrieved in order to give you that information, so that you can actually go and verify the source, whether it's a real legit source, whether it's a source that maybe it's not satisfying your needs. So access to search engines is one thing that RAG can do, but it can also retrieve information out of the data that you provide to it. So it doesn't have to be search engine. It can be just like a data set, like a simple CSV file or a text file that's residing locally on your machine that has transcripts or on a given client call, let's say, and you want to understand, the summary of the call, or you want to ask particular questions about this call without having to go through the entire thing. You can ask the model to do that, and it's going to use that information in order to help you figure out what's actually inside of this document and help you synthesize the insights coming from it. And then there's the third mode, which we've already talked about, called connectors, which lets you specify access to any kind of external tool that may help the model to perform this cognitive reasoning and give you the best possible answer. So, for example, this is a example people use a lot, and that's because language models are famously bad at math. Perhaps that's why I'm gravitating towards them so much, because I'm bad at math myself. But they are. So the funny thing is that language models are really great, as I mentioned, at understanding the relationships between words. And they also use this architecture called transformer that really lets them understand that the relationship between the words can be fuzzy. So like some words can be similar to others and not others. And so that's kind of how it conceptualizes whatever data it has. And when you are asking the model to apply the same kind of technique on top of numbers, and so what it tries to answer is whether one is kind of fuzzy of 2 and it is a fuzzy of 4, but it's not how math works. Like you don't really, you have certain rules that math follows, and language models don't have that logic kind of embedded in them. So one of the favorite examples of tools is giving access to the language model to a calculator that is able to perform higher level calculations for you, or even simple calculations for you in a very efficient kind of legit way. So that's one tool. But you have, as we discussed, all sorts of tools when whether it's communication platforms or email inboxes or some sort of ticketing system that you have at your hands, where you want to kind of also search through information in order to make better decisions. So that's also available with RAG. And so these are 3 modes, but the higher level is retrieval augmented generation. So you have a generative model that is able to go outside to external sources of information, retrieve them back, generate the response based off of the source, and then provide citations as a reference point. So you can go and verify the source of information, so that you are not kind of left with, so this is the answer and that's it. And I'm not going to explain how I came up with this.
Well, that sounds very similar to, or sounds like it addresses the one of the killer app problems we were talking about earlier with the information in email and Slack and other tools, and being able to connect and get that information for you. I want to find out more about that. So, well, I mean, so this is been, first of all, thank you so much for this conversation. But before we, just one closing question and thought. I always like to ask, and especially given what you're doing, what advice do you have for like businesses and individuals who are looking to find out more about LLMs and GPT? What's like where should they stop first to find out more information?
Awesome. I love a question like this because that's what I do. I try to educate people and I try to bring them closer to this domain. I know it can sound overwhelming at first with all the acronyms, new tech, all the updates, etc. But it really depends on what you're trying to achieve. So first of all, number one advice would be don't fear it. Don't feel intimidated by it. We are all trying to figure out as we go, and even the researchers that are currently working on developing this technology, they also have the imposter syndrome. They also feel like they haven't read enough papers, and that the progress is outcompeting their knowledge about the field, etc. We are really in this very very dynamic moment where all of us are trying to catch up. All of us are, overwhelmed with the number of updates that are happening. So that's number one. Don't be intimidated. Just try and find your way to it in a way that fits the purpose and the kind of the level of knowledge that you have and want to have. So if you're an individual and let's say you are an engineer, you are a technical person and you just want to understand it better, be able to understand the concepts associated with language models, perhaps experiment with some example implementations of working with large language models, then luckily you're all covered. There are excellent resources out there, starting from something we call Large Language Model University, LLM University at Cohere, where we created a course that is covering all of the fundamental concepts associated with LLMs, along with technical implementation examples, so app examples of any particular concept that we are covering at any given time. And we are covering things from what transformers are to RAG and the latest kind of advancements in the field. So LLM University course is one example. There are plenty other courses on prompt engineering, more detailed ones. Depending on the type of depending how deep you want to go, you can find resources, high quality resources online out there that will help you go through it. I also always encourage people to join a particular community that, imagine large language models blew up and there are so many other folks like you that are trying to understand what's going on, trying to catch up. And this is something new and that they want to wrap their head around. Discord communities in particular are a really, really nice place where if you're using particular model, whether it's Cohere, OpenAI, Stable Diffusion, there's a Discord for every model, for every framework out there. You can join it, you can converse with others, chat with others about the type of questions you have, the type of issues you come across, and try to learn from each other. Also following folks that are in this space is a really good idea, because then you can get up to speed with what's happening, what they are working on. So whether it's, researchers on LinkedIn, machine learning engineers, or LinkedIn developer advocates like me on LinkedIn, Twitter, and other platforms, it's always a good idea to kind of keep in touch. And then for the business, my advice would be, so the first advice would be similar. So don't be intimidated and try to start grasping it and wrapping your head around it and how it can be relevant to your business, because it's not going away. And there are plenty of other businesses out there that are going to leverage it as a competitive advantage. So if you want to keep your edge, you really want to dive into it, you have to. You don't have a choice. I don't think you have a choice. It's almost like being in the era of personal computers, the adoption of personal computers, and kind of trying to stall it or negate it. So don't do this. It's going to happen one way or another. So please try to adapt it. And then depending on the size of your business, it's also good to look at the different options that you have in terms of the model offerings. So you have these foundation models that are either proprietary, like Cohere, OpenAI, Anthropic, and whatnot. And then you have also open source models that you may want to experiment with and work on for a particular use case to see whether they fit. Or maybe it's a combination of those. It always depends on the type of use case. Then think of an example use case that would be kind of low risk to implement at your company. And that's why companies like to go for this internal chatbot, because, worst case scenario, if things backfire, you can always scrape it and it doesn't have much implication to your product. So think of implementing something internally so that your employees can get hands-on with it, can get excited about it, and can start thinking about ideas in which this type of technology can be applied to actually your offering, your services. Because it's kind of, if you want to innovate with this technology, you also need your people to understand what it is and what kind of value it brings. So start with something internally, get people on board, and then think of implementing something client-facing, external as well. That would be my recommendation. And yeah, look around and look at different alternatives. Look at multiple different options. It's always good to have kind of a breadth of understanding and a lot of options to choose from when you're working with LLMs. It also depends on your current technical setup. So as I mentioned, we at Cohere, we are working with all cloud providers. We're cloud agnostic basically, but there are companies within the space that are working with a particular cloud provider. So if your entire kind of business resides in AWS, you are not going to be able to use OpenAI's models. I'm sorry, but this is not going to happen. So it also depends on that type of thing.
That's great. And you also have videos and a podcast, as you mentioned, that I'm going to be watching. I don't know how many episodes you have right now, but I'll binge watch them and then catch up so that I can begin watching those. So that's at SandraKublik.com. Is that what you said?
So that's my personal website. You can find all of my activities on that website. But the podcast is the Sandra Kublik podcast. You can find it on Apple, Spotify, and YouTube, the video version of it. I also have a YouTube channel where I add educational content in the form of short videos. Wherever there's like a bigger thing to cover, like LLM specific tools that you want to use as a developer, or things like that. I like to dive into those, and also get in touch with me if you have any particular question about this technology, especially about Cohere, which I'm the best versed in at the moment. Connect with me on Twitter, ask me a question. I'm so happy to answer and point you further, because I'm pretty sure there are resources that can help you get a better understanding of whatever it is that you're trying to figure out.
Well, fantastic. Well, thank you again so much for your time. I know we're in a different time zone here. It might be a little late there, but I really appreciate your time, Sandra, and appreciate what you're doing. And thank you so much for agreeing to be here today.
Thank you so much, Paul. I really enjoyed the convo. And I love the types of topics we've covered today. And thank you for having me.
Thank you. I hope you enjoyed the show, Driven, with me, Paul Perrone, your host. Don't forget to check us out at driven.show on the web. And give us a thumbs up or subscribe here if you like the show. Thank you for listening in. See you soon.